Okay, so now potential simplification for calculating the growth rate. Now, I'll post a brief kind of write-up that's just extra that kind of explains why this is true. So I don't want to get into too many of the details right away, but a nice feature is that if the growth rate is small, so roughly speaking less than 10%, somewhere in there, 10 to 20% tends to be okay. Once the growth rate gets larger, this approximation isn't going to work as well. But for relatively small growth rates, year-to-year type of growth rates, this works good. If GT is small, then the growth rate is approximately equal to the difference in the natural log of a variable. So the natural log we call ln. So it's the inverse of the exponential function, or e to the power x. So we'll do some examples here where we can see this in action. But that's a really nice feature, and let me kind of show you why. So this is taking numbers. So I'm going to just kind of flip to a different page here so we can keep track of this. So 2013, the real income per person was $49,247. 2014, that number was $50,051. Okay, so let's just kind of look at growth rates and how we can use the log transformation to make our lives potentially easier. So let's calculate just the actual growth rate here. So the growth rate is the difference in the variables, so the new one minus the old one divided by the old one. Right, and so I think that you get like, let me just think you get like about 1.6%. So you can calculate that on your own. I think it's 1.62 or 1.63% is the growth rate there in per capita GDP between these 2 years. So now let's look at what if we, and to kind of put our data in kind of a table format here. And let's take the natural log of the variable. So your calculator should have this. In Excel, you can use the natural log. So let's see, natural log of 49,247 I get is 10.8046. So make sure that you can get these same numbers, and log of 50,051 is 10.8208. Okay, now you say, what's the big deal? How is this helping me? Well, if I get my data that I'm using, so let's say I work for a company, and one of the things that companies like to calculate is growth rates between quarters or over the year, whatever the case is. And so you have the data, and you can calculate the growth rate using the growth rate formula here. That's no problem. If you put the data into logs, so right when I get the data, I calculate the log, I can quickly look at these two and get a sense of what the growth rate is just by subtracting them, right? So remember, GT is approximately equal to the difference in the natural logs. And here, that's 10.8208 minus 10.8046, which is 0.10 0.0162, 1.62%. So I think up here this is 1.63%, the actual. Here's our approximation, is a very good fit, right? So notice, if you just look at those, eyeball them, you're going to say the growth rate is somewhere around, 1.5% when I just subtract them quickly. So that's kind of a handy trick. It's a really good way to work with data, especially when you're mainly concerned with the growth rate, is that you can look at the log of the variable, natural log of the variable, and then simply subtract two consecutive numbers, and you've got an immediate approximation of the growth rate, and one here that is pretty good. Okay, so here's the log of our per capita income over time. And so the point here is that when I look at this, the slope of the line is telling me the growth rate, right? Or an approximation of the growth rate, because that tells me the difference between the two variables. So, we notice that the growth in real GDP was very high, growth rate was very high, coming out of the Great Depression through World War II. And then we've had assorted ups and downs over time. But that's a classic way that macroeconomists work with data, is to use the natural logarithm, and then we get a very easy sense of the growth rate just by looking at consecutive numbers. All right, so let me just, before we get into there, I want to have you at the end of this, go ahead and work through this example, calculate the growth rate between consecutive years. So you're going to have a growth rate in 2017, 2018, and 2019. So we can't do the first one because we have to subtract consecutive years. But calculate the actual growth rate, then calculate the growth rate using the log approximation, and I will post the solution, and you can kind of compare and make sure that you've got this neat trick down. All right, so then we'll just have one more video here in this section where we just kind of talk about what we look at when we're measuring business cycles versus economic growth.